Good afternoon, class 10. Today we'll continue with the next part of the same chapter, that is radioactivity. In the last class, we spoke about the unit of radioactivity. We spoke about the uses of radioactivity. We spoke about the changes in the nucleus on alpha, beta, gamma emission. Okay, so today we'll speak about nuclear reactions. What are actually nuclear reactions? There is some specificity of a nuclear reaction which makes it different from a chemical reaction. Okay. Now, in case of nuclear reactions, the energy emitted is very, very huge. We'll be doing it in your nuclear fission and fusion. Okay. So, in nuclear reaction, in a nuclear reaction, the mass of product obtained is much lesser than the mass of reactant. This results in loss in the mass. This lost mass is known as mass defect. This is very important. In case of a nuclear reaction, always if you compare the exact mass of a reactant and exact mass of a product obtained, always the mass of product will be lesser than the mass of the reactant. Right? Now there will be loss in the mass. Now this is known as mass defect. This is very important. This is known as mass defect. Now, this loss in mass is represented by delta M. Now, this lost mass can be converted to energy given by Einstein's equation. This lost mass can be converted to energy. Delta M is the lost mass. Now this lost mass we will convert to energy by Einstein's relation E equals to delta M C square. This is your Einstein's equation where Einstein's equation, where mass and energy, they can be converted. Now the terms E, energy. This one we have already said, the loss in mass when reactants form the products. And C is the velocity of light. C is velocity or speed of light. Okay, this is very important. This equation is very important. Actually, the concept beside this equation is very important. That is, in case of nuclear reaction, there is a loss in mass on forming the products. That mass gets converted to energy, which is released in a nuclear reaction. We have two types of nuclear reaction, that is nuclear fission and fusion, where we get large amount of energy. We'll be studying that in details. That energy comes when this loss in mass or the lost mass gets converted to energy. That's why we get so large amount of energy. Now this thing is never possible in a chemical reaction. Okay. Here the lost mass gets converted to energy. Lost mass gets converted to energy. Now we'll do the types of nuclear reaction. First we'll start with nuclear fission. So I'm rubbing this. Nuclear fission. This is under nuclear reaction number 1. Now first we'll speak about the definition. Now from the definition itself, nuclear, so we know it means nucleus. What is the meaning of fission? Fission means breaking down, splitting. Fission means splitting. So what should we write? What should be the definition? It is a process in which a heavier nucleus splits into two lighter nuclei. And large amount of energy is liberated when slow neutrons strike it. It is a process in which heavier nucleus splits, means breaks down, splits into lighter nuclei, two lighter nuclei, and large energy. Okay, when it happens, when slow neutrons strike this heavy nucleus. When the slow neutrons are going to strike the heavier nucleus, that heavier nucleus will get splitted into two lighter nuclei and huge amount of energy or large amount of energy. This is the definition of nuclear fission. Now we'll do the equation. Equation under this. Very common equation we have. Uranium 235. Uranium 235 92. When slow neutrons means, obviously, as a term indicates, its speed is very lesser. Slow neutrons strike the nucleus. We are going to get products as barium 144, then 56, plus krypton 36, then 90, plus 2 neutrons will be liberated on the product side. Okay, and plus energy. This is the reaction. Left hand side we have uranium 235 92 and 1 neutron. Right hand side, there is a product part, we are going to get this barium, we are going to get krypton, 2 neutrons plus the energy. And from where this energy is liberated? The energy is liberated from that loss in mass, because this is a nuclear reaction. We are having a radioactive nucleus. Okay, it is forming two products, and this energy, it is coming from the lost mass which gets converted to the energy given by Einstein's equation. This is the basic reaction of a nuclear fission. Now, in this process, we are getting 2 neutrons on the product side. So what is the significance of that? That is also again important. This being a nuclear reaction, you have to check once the left hand side atomic number, mass number, and the right hand side atomic number, mass number is balanced. Okay, it will always be balanced. If suppose it is not balanced, that means you are doing some mistake, but this is balanced. I have checked it. But while writing this, once you have a look on it. So now the significance of fission reaction. Fission reaction. Now, if you follow the equation, here 1 neutron strikes or collides with a uranium nucleus to give you this products, 2 neutrons and energy. Now, since neutrons are required for this reaction to undergo, the 2 neutrons which are emitted in a given reaction that can separately react with this uranium nuclei to produce more number of neutrons. Okay. It involves release of neutrons which can separately strike uranium-235 giving products. Obviously the products will be the same products, that is barium and krypton, giving products and more neutrons. This starts the chain reaction. Chain reaction means a continuous reaction is started. A continuous fission reaction starts. This starts a chain reaction which continues till the entire amount of uranium-235 is consumed. So this is actually chain reaction is. That this is the significance of a fission reaction. It gives rise to a chain reaction. Chain reaction, why? Because here the reactant side also we are having neutrons, product side also we are having neutrons. So if the neutrons are separately reacting with this uranium nucleus, then again it will give the same reaction with emission of large amount of energy and neutrons. So this will continue. So this continuous process is called the chain reaction. Till the entire amount of uranium nucleus gets consumed, the process will go on and on. On the basis of this, we can classify the reaction into 2 types. Number one is your controlled chain reaction. Basically, they all fall under fission reaction. Number one is controlled chain reaction. Controlled chain reaction. Number 2, uncontrolled chain reaction. Which we will continue in the next video. Okay, thank you.